So here we go. I can tell that it's going to equal 0 at 3, and I want that because it's got the equality. It's an even multiplicity, so I'm going to put a star next to that for later. This one here, x equals -1, I'll equal that because it's equal, and I'll put a star next to this because it's an even multiplicity for later. -1/2 is also to an even multiplicity, so I'll star that. And then -2/3 is right in between there. And it's to an odd multiplicity, so I don't need to star it. It'll change signs like normal. So now I'm going to plug in anything I want bigger than 3. A billion, you knew it. Billion minus 3 is squared, so it's positive anyway. To the 4th, so it's positive anyway. To the 4th, so it's positive anyway. But if I put in a billion times 3 is 3 billion plus 2, that's still positive. So we're positive over here. Now, here we go. This was starred. It came from something with an even multiplicity, so it doesn't matter whether I was slightly bigger than 3 or slightly smaller than 3. This thing is positive anyway. It doesn't change to negative, so it won't change the sign of the entire thing. So if I was positive on this side, I stay positive on that side. Cool. I do it again. This one came from an even multiplicity also. So it doesn't matter whether I put in things slightly bigger than -1/2 or slightly smaller than -1/2. This is always positive. It will not change to negative, so it will not change the sign of the entire thing. It's positive on this side. It stays positive on that side. This one came from an odd multiplicity. That was to the 1. There was nothing there. And so if I do go a little bit bigger than -2/3, it'll be positive, but if I go a little bit smaller than -2/3, it'll be negative and send this whole thing to being negative. So I will change signs from being positive to being negative over that -2/3. Gotcha? Get me? All right. And then again, this one was from an even multiplicity, so it was negative on this side. It is going to stay negative on that side, because it just being slightly positive or negative doesn't change it. So I remember when I was taking this class, I used to try to find numbers between -2/3 and -1/2 and plug them in, and oh God, it was a pain in the butt. But once you have one, and be very confident about your first one, because otherwise they're all going to be opposite. Once you have the one, you can just do that all the way down, and it's beautiful. So we can finish answering the question, what do we want? We want things that are less than or equal to 0. So I'll take all of this that's negative, right? So just this stuff here and this stuff here. And because I want stuff that's less than or equal to 0, I can equal that, and so I can describe this just as this one region starting from -infinity and going to -2/3. And that's it. I didn't want any of this positive stuff. Cool. If you were to link this to the graphs, the polynomial graphs that we've been doing, if you were to graph y equals this mess, it would have zeros at, this will be grossly not to scale because these are all kind of close together, but we'll say -1 is right there, and -2/3 and -1/2, and over here we'll say that's 3, and it's equaling 0 all there, there, and there. Because these came from even multiplicities, I will star them, the -1, the -1/2, and the 3. It's going to bounce there. Whatever sign it was before, it's going to stay that sign. So now I check where I start. The degree of my entire polynomial would be 2, 6, 10, 11. So this would be like x to the 11th plus something, something, something. So that's odd. So it's going to start down and up. And so I'm going to be up here and then down there. And now I can just kind of work my way through. So I start up. When I come here, I'm going to bounce off the 3 because it stayed positive. And then when I come down here, I'm going to bounce off the -1. When I come here, I'll go straight through the -2/3, When I come here, I'm going to bounce back off that guy there. Anyone was starred, was even multiplicity, he bounced, he stayed the same sign. And yeah, grossly out of scale, right? I don't know how far down and how far up it goes without calculus or plugging in values, but that's a rough look of what it looks like. And there you have it.